So here is the homework review for part 2 of 3-7. We are going to start with number 7, and the directions there say solve and graph each inequality. Notice it didn't say check, but I'm going to, of course, expect you to do checks. So number 7 is x is, the absolute value of x is less than 5. So we're starting out with the absolute value of x is less than 5. Less than, of course, is an AND equation. So we should end up with those graphs that come in and meet each other in the middle. And it also means that we can combine our inequality to look like this. And look at that, it's already solved. Wow. So we graph, and we do not have the or equal to, so we use open circles. Remember, you read it from the x and say x is greater than -5, x is less than 5. So those meet in the middle nicely. And when we do our checks, we are going to have three checks. We want something to the left of -5 to put in here, so we can say -6. We want something in the middle, which I like to use 0, and then we could say +6. We're hoping that these do not work, and this does work, which you can very quickly see in this one is what is going to happen, because 6 is not less than 5, 0 is less than 5, and again 6 is not less than 5. So that is your complete solution, graph, and check for number 7. For number 9, we have the absolute value of y plus 8 is greater than or equal to 3. Greater than or equal to tells us that this is going to be an OR. So we're going to need to set up two separate inequalities to solve. Remember that when you make this number negative, you have to flip that inequality around. For the positive, it just stays that way. And then we are solving this for y. We get our solution, which is y is less than or equal to -11, or y is greater than or equal to -5. You might notice that this one does not pass 0 in the middle, but it is an OR where our graphs go out. We're then going to check and with our ORs, we want 2 good checks and 1 bad check. For one of our good checks, we need something less than -11, which -12 works. We solve that out and we get 4 is greater than 3, which is true. For something in the middle, we need something between -5 and -11. I'm going to use -8 here because it works very easily. And you can see that we get something that does not work. 0 is not greater than or equal to 3. And that's good because we wanted something that would not work. In this last one, we want something over here. So here's where we can use 0. If 0 is greater than -5. And we get 8 is greater than or equal to 3, which is true. So we know that our solution set was a good one with y is greater than or equal to -11, or y is greater than or equal to -5. This is number 11. With number 11, we have the absolute value of p minus 7 is less than or equal to 3. So with a less than or equal to, we know this is going to be an and. So we can set up our solution like this. We're going to add 7 everywhere. We get that for our solution. Close circles this time. Did you hear my dog snore there? Close circles this time, and we have an and. Just going to look like that. So we have p is greater than or equal to 4, p is less than or equal to 10. And then we are going to do 3 checks. We're going to expect that 2 will not be true, and 1 will be true this time. So for the one that is not going to be true to the left of 4, we could use 0. Seven is not less than 3. For something in between, let's use 8. One is less than or equal to 3. That is true, which is good because it's where it should have been true. And then we need something bigger. Let's use 12. We get 5 is less than or equal to 3, which of course is not true. So there's number 11. Have number 13, which is the absolute value of 5t minus 4 is greater than or equal to 16. The greater than or equal to lets us know that this is going to be an or when we solve it, meaning we are going to need to write this in 2 distinct inequalities. We're going to say negative 16 is, sorry, I'm pausing for a moment here. So negative 16 is greater than or equal to 5t minus 4. I'm writing this backwards. And then 5t minus 4. So we are going to go about this 2-step inequality by getting rid of the minus 4 first. And we're going to divide by 5 everywhere. Excuse me. So we have t is less than or equal to negative 12/5, or t is greater than or equal to 4. No common factor between 12 and 5, so that's fine to leave like that. We have closed circles here, and our errors are going out because it's an or. Just double check. So t is less than or equal to, go that way. T is greater than or equal to, we go that way. So those are good. We need 3 of our original inequality. Remember to write all 3 exactly like they appeared at the beginning of your problem. And then in this case, because it's an or, we're looking for 2 checks that will work and 1 that will not work. For, let's see, for our one that will work, we want something over here. Think about this as a proper fraction. it would be -2 2/5, so we could say -3 here. I get -15 minus 4, which would be -19, which is 19. 19 is greater than or equal to 16. For something that will not work, I'm going to plug in 0. And 5 times 0 would be 0. 0 minus 4 is -4. -4 is greater than or equal to 16 is not true, which is perfect because we didn't want it to work. And then something greater than 4, I'm going to plug in 5. So we end up with 21 is greater than or equal to 16, which is true. It worked out perfectly because we were looking for 2 checks that did work and 1 check that did not work because we had an OR here. So we have showed that all of our work for number 13 is good, and our solution of t is less than or equal to -12/5, or t is greater than or equal to 4 is a good solution. All right, so number 15, we have the absolute value of 3d minus 7 is greater than 28. Greater than means that this is going to be an OR. So we are going to have to split these. Remember to flip that inequality on your negative side. Oops. Just greater than, so you'd have a less than and a greater than. And then we are going to solve this two-step All right, so there are our solutions. We can then graph them. And we have open circles. D is less than or D is greater than. So it does come up with our graph to be an OR. We are going to do 3 checks. We should have 2 that work and 1 that does not work. So with our first one, we want something that's smaller than -4/3, so we could say -2. And get -6 minus 7, which would be -13. The absolute value of that is 13. And so looking like I made a mistake. Because 13 is not greater than 28. So let me look at this. Oh, right here. I was dividing instead of adding. I bet some of you caught that. So this would be -21, which would make this -7. And then on that side, I did add. So this becomes -7. And I hope you kind of notice why our checks are so important, because they do occasionally show you that you need to go back and figure out what went wrong if you made a mistake. So I now need something that is smaller than -7. I'm going to say -10. So I get negative 37, which is 37 is greater than 28. That is true. Now we go to our check that should not work. I'm going to plug in 0. Which we get 7 is greater than 28. Which of course is not true, and it shouldn't be because it was in that in-between zone. We need something that is greater than 35 thirds now. If we think about making that into a proper fraction, it would be 11 and 2/3, so 12 would be bigger than this. So if we could use 12 in here. 29, and 29 is in fact greater than 28. Oh, you guys see that? There you go. So that does work. This one did work, and the one in the middle that should not have worked came out not true. So we are good to go with our solution set of D is less than negative 7 or D is greater than 35 thirds. Make sure you do write that or in there so that it stands out that you know this is an or, and your graph also shows that it is an or because your arrows are pointing out. Number 17 is a word problem talking about women's basketball. It says that women's basketball is 28 7/75 of an inch, but the actual circumference can vary from the ideal by at most 1/4 of an inch. So what are the acceptable measurements for a women's basketball? You would set this up a whole lot like problem 5. So I kind of forgot to hit record and wrote my equation, which was the absolute value of C minus 28.5 is less than or equal to 25/100 of an inch. When you do this, you're saying that the difference between the measurement and the standard size that they want the balls to be, it's going to be no bigger than 1/4 of an inch. So it can go either smaller or bigger. That's why the absolute values are there. So then you split this up because our absolute values are alone on one side of our inequality. Remembering to flip your inequality for the negative. Just leave it the same for the positive version, and then I am adding 28 7/75 everywhere, and I get that C is greater than 28.5 inches and C is less than or equal to 29 inches. So our basketball can be between 28.5 inches and 29 inches inclusive, meaning closed circles, and it's an and. That one was a word problem, so you don't have to check it. The last one is number 19. And number 19, you may notice right away, hopefully, that our inequality is actually on the right for number 19. So we have 7/8 is less than the absolute value of C. I think it's plus, yeah, C plus 7. So the first thing I would do here is rearrange this so that our absolute value is on the left, which means we're going to flip our inequality. And now I can say, okay, well, I'm dealing with a greater than, so that's going to be an or. And we can, hang on, we can go ahead and split this inequality because our absolute value is alone. So we're going to say C plus 7 is less than negative 7/8 and c plus 7 is greater than positive 7/8. I'm going to subtract 7 everywhere and get c is less than, we have 2 negatives, so we're going to add, so it'd be negative 7 and 7/8. And on this side, I get c is greater than, and I have a positive and a negative. So I would really subtract and say negative 6 and 1/8. And then we can graph open circles. And our arrows are going to go out because this is an OR. So we have c is less than negative 7 and 7/8, or c is greater than negative 6 and 1/8. And when I do my checks, I want 1 to be over here, 1 to be in the middle, and 1 to be on the right. So I'm going to go back to my very original before I changed anything. So I'm going back to that. And I need to write it 3 times. And the first one, I want something that's less than negative 7 and 7/8. So I'm going to go ahead and put in negative 8. 7/8 is less than 1, which is true. And here I want something between negative 7 and 7/8 and negative 6 and 1/8. So I am going to use negative 7 here. We get the absolute value of 0, which is 0. 7 is less than 0. That is not true, which is perfect because it's in our land where it should not be true. And then we need something greater than negative 6 and 1/8. So I'm going to use negative 6. And we get 7/8 is less than 1. Oddly, the same thing I got over here. And that is also true, which it should be because it's in the land where it should be true. So this is your solution for number 19. Go ahead and check your homework. Make sure you're writing down any questions that you might have so that you can ask them either in a future Zoom or on your class's math discussion board. And I will see you soon with lesson 3.8, which is actually the last lesson in chapter 3.